Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes. We will discuss a few formulas of inverse trigonometric functions. Alright, so this class is about the synopsis. Alright, so I will go in detail about all the formulas that are related to this chapter. Now first let us understand existence of this inverse sine function. Alright, so when do you think this sine inverse function will exist? Now let us understand what do you mean by inverse function. Okay, forget about trigonometry. What do you mean by inverse function? So let us understand that first, then we can understand inverse sine or inverse trigonometric function. Well, now first of all you have a function, let us say f of x is equal to x square, and it is defined on let us say z to z. Now my question is it invertible? Can you find the inverse of this function? Well, inverse will exist only if a function is both on 1 and on 2. A function is invertible if and only if it is bijective. Alright, now let me plot the arrow diagram for this, you will understand clearly. Okay, so I'll just take some numbers. You have 0, 1, 2 and all. So you have minus 1, minus 2, 3. Okay, so it is z, and then again you have z here also. Okay, alright, infinite. Well, now understand f of x is equal to x square. So what about f of 0? F of 0 is 0 square, which is 0. F of 1 is 1 square, which is 1. What about f of minus 1? Minus 1 square. Okay, so understand, f of minus 1 is minus 1 square, which is 1. So minus 1 will go to 1. Alright, what about f of 2? F of 2 is 2 square, which is 4. So 2 will go to 4. What about minus 2? F of minus 2 is minus 2 square, which is also 4. So minus 2 also will go to 4. Similarly 3 will go to 9, minus 3 also will go to 9. Now my question is it 1 1? Is it 1 1? No, this is not 1 1. Okay, many elements go to one image, so it is many 1. I hope you know that difference. Okay, so the opposite of 1 1 is many 1. So this function is many 1, therefore this is not bijective, therefore this function is not invertible. That means you cannot find the inverse of this function. Okay, so why you cannot find the inverse? See, if you express the function, then you have to write this way. Alright, you have to write like 0 comma 0 and 1 comma 1, even minus 1 comma 1, correct, and 2 comma 4, and minus 2 also goes to 4. So this is the way you have to write it. Infinite. Okay, it is not finite set. It's the infinite set, right? Now when you write the inverse, 0 comma 0 reverse, correct? 1 comma 1, 1 comma minus 1, you have two things. So with 1, which element do you write? What is the pre-image of 1? The pre-images are 2. So do you have a unique pre-image? You don't have a unique pre-image. So if you don't have a unique, see, I'll write this. See, this is 1 comma 1 and 1 comma minus 1. Okay, so this will be, see, this function is f. Now when you write f inverse, this is also z. I'll give only a few examples. Okay, so I'm writing f inverse. I'm going back now, so 0 and 1. Okay, so you have 1 here, minus 1, everything is there, correct? Okay, so according to this set, 0 goes to 0, fine. Then 1 goes to 1, correct? So 1 goes to 1, and what about 1 goes to minus 1 as well. So 1 goes to 1 and 1 goes to minus 1 as well. Now what is happening here? Is you don't have a function at all. What is the definition of a function? Every element of the domain has one and only one image. It has one and only one image. It has a unique image. Now the element 1 has more than one image. So this is not a function at all. Okay, this is not a function. So if it is not a function, how it can be inverse function? It cannot be inverse. So when inverse will exist? Only if it is bijective. So only if it is both 1 1 and onto, then only inverse will exist. Forget about okay, so now we are done with 1 1. Now what about onto? Every element should have a pre-image. Okay, so every element must be image of some element of the domain. Every element of the codomain must be an image of some element of the domain, then only it will be onto. Now imagine, don't imagine, okay, you have the examples. So you have minus 1, you have minus 2, you have minus 3. So minus 1, does it have a pre-image? So you put any element here, do you get minus 1 here? No chance at all, because square of anything will be positive. It won't be negative at all. Okay, so these elements don't have a pre-image. So what about this element? Is it related to any element? No, whereas 2 is related to 4, right? Okay, and 2 is related to minus 4 as well. Okay, forget about that. Now understand this. What about minus 2? Minus 2, does it go to anything? It does not go to anything. You will never get minus 2 here. So you will never get minus 2 in the first place. You will never get minus 2 here. You will never get minus 1 here. So these elements don't have an image. But what is the definition of a function? Every element must have one and only one image. Every element must be related. Now these elements are not related, therefore this is not onto. Okay, so if it is not onto, then also it won't be a function. If it is not 1 1, then also inverse won't be a function, will not be a function. Therefore to find the inverse, we need to have a bijective function. I hope you understood that part. Now let us go for inverse sine function. Okay, all right, the inverse sine function. First, what is sine? So sine is from real numbers to -1, 1. Correct? So this is the sine function. Alright, now if you want to have a better picture of this, alright, I'll give you some examples. Alright, I'll give you some examples. What about sine of I'll start with the 0. Okay, so sine 0 is 0. What about sine 90? What about sine 90? Is 1. Correct? And what about sine 180? It is 0 again. What about sine 3 pi by 2? It is -1. And what about sine 2 pi 360? It is 0. And come to the negative part. See, what about sine minus pi by 2? That is minus sine pi by 2. Minus sine pi by 2 is -1. Then what about sine minus pi? Sine pi is 0. Minus sine pi is also 0. Okay, so I hope you know this formula. Sine of minus x is minus sine x. Okay, then what about sine minus 3 pi by 2? So that will be minus sine 3 pi by 2. So minus of minus will be +1, and then sine minus 2 pi. So sine minus 2 pi is 0. Right? Okay, now let us plot the graph. Alright, so when you plot the graph, on the y-axis you have 1 and you have -1. Okay, and you have 0 here. So these values are only 0 between -1 to 1. See, if you take sine 45, sine pi by 4, you will get 1 by root 2. If you take sine 30, you will get 1 by 2. Correct? So all those values are there. Okay, it is not that only -1, 0 and 1. All the values between -1 to 1 are there. But on the x-axis we have the angles. So I'll take 90 degree and 180, 270 and 360, and here -90, and here -180, -270, and then -360. Okay, now first sine 0 is 0, so that is 0, 0. Then 90, sine 90 is 1, so for sine 90 you will get 1, and then 0, and then -1 here, and then 0. So similarly here, so you have 0, and then for minus you have -1, and then 0, and then +1, and then 0. Correct? Now the graph will be like this. Right? So this is the way you draw the graph of sine function which you have learnt in first year. Now understand, what about the inverse function? See, to have an inverse we must have a bijective function. Now tell me, is it bijective? Is it bijective? It is not bijective because you have all the real numbers and you have the elements between -1 to 1 here. Okay, so you have 0, you have -1/2, I'm taking only a few. Okay, so you have minus 1 by root 2, minus root 3 by 2, minus 1, so you have half. Okay, now sine 0 is 0. What about pi by 3? Pi by 3 will go to half, minus pi by 3 will go to minus half, pi by 6, I'm sorry, 60 degree. Okay, and then you have pi by 4, 1 by root 2, minus pi by 4, right? Okay, so now this looks like this is 1 1, but is it actually 1 1? So for that sake I will write these values. Okay, so you understand, I will write these values. Okay, so you have 0, then you have pi by 2, you have pi. Okay, if you still need, I'll write 3 pi by 2, and this is minus 90, and this is minus 180, minus 3 pi by 2, and so on. Okay, now sine 0 is 0, right? And what about sine pi by 2? So sine pi by 2 is sine pi by 2 is 1. Okay, now sine pi, when you write, what is sine pi? It is 0. So sine pi is 0, don't write 0 again, 0 is already there. So sine pi will go to 0. And what about sine 3 pi by 2? That will go to minus 1. Okay, and what about sine 2 pi? 2 pi will go to 0. By this itself you can understand. Okay, so look at this. If you want a clear cut graph, I will write only a few values. Okay, so only a few values. So first 0 is 0, then what about pi? Pi is also 0. So is it 1 1? No, it is not 1 1. Okay, so what about pi by 2? Pi by 2 is 1. What about minus 3 pi by 2? Minus 3 pi by 2 is also 1. So understand, 2 elements, 1 image. 2 elements, 1 image. Not only 2 elements, there are 3 elements, there are 4 elements, there are infinite elements going to 0. Correct? So you have sine 0 is 0, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, 4 pi is 0, 5 pi is 0, sine 6 pi is 0, everything is 0. So you have infinite elements here in the real numbers which go to the image 0. So it is not 1 1 at all, many elements, one image. So can you find the inverse? When you find the inverse, it won't be a function at all. So you cannot find the inverse. Therefore what we need to do is we have to restrict the domain. So domain must be restricted. Now I will restrict the domain from minus pi by 2 till pi by 2. Okay, so minus pi by 2 pi by 2, or you can restrict the domain from pi by 2 to 3 pi by 2, or you can restrict the domain from minus pi by 2 to minus 3 pi by 2. So any one of these, either this domain or this domain or this domain. Okay, so you can restrict the domain, but usually what we do, we restrict the domain from minus 90 to 90. Now is there any value that is repeated here? See, here 2 values are repeated. If you are taking from minus 3 pi by 2 to pi by 2, you will get 1 and 1 repeated, 0 and 0 repeated. if you take from minus pi to 0, then these two values are repeated, correct? If you are taking from minus pi to pi by 2, then again these two values are repeated. If you are taking from minus pi by 2 to pi, then these two values are repeated. So what we need to do is we have to select a branch where the values are not repeated, where the images are not repeated. Okay, so between this, no image is repeated. Okay, so every element, every angle here will have a unique value, will have a unique y value. Therefore, now what we do is we define the function from minus pi by 2 to pi by 2 till minus 1 to 1. Okay, so this is the way we select the branch, and this is called the principal branch of sine, okay, inverse. So now you define sine inverse. So what is sine inverse? The sine inverse is from minus 1 to 1. Okay, so it is the reverse, right? So for every, one second, we'll complete writing this. Okay, so if you have a function from x to y, then what will be the inverse? Inverse will be from y to x. Okay, the domain and codomain will be interchanged. It's changing of domain and codomain. That's how we get the inverse function. Now what is sine inverse? Minus 1 to 1. So this graph will be toppled like this. Okay, so now the x values and the y values are different. So what are the x values? X values are these, minus 1 to 1. So you have x values minus 1 and then 0 and then 1, and the y values, okay. So what are the y values? Y values are these. Alright, so you have 0, you have if you want, I'll write pi by 6, pi by 4, pi by 3, pi by 2. Okay, so similarly here, so minus pi by 6 and minus pi by 4, minus pi by 3 and minus 90. Okay, so you have values only from minus 90 to 90 in sine inverse. Okay, so first you have sine 0 0. What about sine inverse? Okay, so sine inverse of 0 is 0. What about sine inverse of half? Okay, so what about sine inverse of half? It will be pi by 6. It will be pi by 6. Okay, so understand this connection. Sine pi by 6 is 1 by 2. Correct? Sine pi by 6 is half. What about sine inverse of half? Sine inverse of half is pi by 6. Alright, so similarly it goes on like this. Okay, so you have this angle and then this angle, and sine inverse of 1 is 90, so it will be a graph like this. Alright, it will be 1 here, so only this branch, that's how it will be. Alright, so this is sine inverse graph. Similarly, you can understand cos inverse, okay, and tan inverse and all those things. Well, so this is about the inverse of sine, inverse sine function. So understand the inverse sine function. The domain is minus 1 to 1 and the codomain is minus pi by 2 to pi by 2. Alright, so that's the domain and the codomain, and this is called the principal branch. So there are other branches also, there are other branches and they are infinite, but we select one branch to make it 1 1, and that branch is from minus 90 to 90. Okay, so that's therefore that is called principal, the main branch there. All right. Similarly you have the cos function. Okay, so we have the inverse cos function. All right, so the inverse cos function the domain is again R and the codomain is minus 1 to 1. Okay, but now the things are different here. All right, so why the things are different here? Because of its graph. All right, so understand, what about cos 0? Cos 0 is 1. And what about cos 90? Cos 90 is 0. And then cos 3 pi by 2 minus 1, and then cos 360 1 again. Okay, cos 90, I'm sorry, cos pi I should have written. Okay, so what about cos pi? Cos pi is minus 1, and then cos 3 pi by 2 0, and cos 2 pi is just like 0, it is 1. Well, if you talk about the negative thing, then cos of minus 90 is 0, cos of minus 180 is 1, and then so what about cos of minus pi? Cos minus x is equal to cos x. So cos of minus pi is cos pi, and cos pi is minus 1. Right, so that will be minus 1 itself. And what about cos of minus 3 pi by 2? That will be 0 itself. Okay, and what about cos of minus 2 pi? So cos of minus 2 pi is cos 2 pi. Cos 2 pi is 1. Now quickly understand the graph. Again, this is not 1 1. Why not 1 1? Because you see 0, 2 pi, both go to 1. Pi by 2 and 3 pi by 2, both go to 1 image. Okay, so it is not 1 1. And you have 90, 180, 270 and 360, minus 90, minus 180, minus 270 and minus 360. Okay, quickly. So cos 0 is 1. So for cos 0 you get 1. Cos 90 will be 0. Cos 90 is 0, and cos pi is minus 1 here, and this will be 0, and 2 pi is 1 again. Okay, so cos minus is 0, cos minus pi is minus 1 here, and this will be 0, and this is 1. Right, so the graph will be like this. Okay, so graph will be like this. Now this is a cosine function. Again we can fix the principal branch from minus pi to 0, or you can fix the branch from minus 2 pi to minus pi to 0, or you can fix between 0 to pi, or you can fix between pi to 2 pi. All right, so you have infinite branches, but which branch do we select? We select this. Okay, 0 to pi. We don't want to go for negative. We don't want to skip this 0. When you have 0 in your domain, it will be very helpful. Therefore, In minus pi by 2 to pi by 2 also we have 0. So we select very close to the origin, okay, very close to the origin. So that is 0 to pi. So that is the principal branch. Okay, so you have a 1 1 function. See, this is not 1 1, this is not 1 1, therefore we have to make a 1 1 function to get the inverse. So now which function is 1 1? From cos from 0 to pi till minus 1 to 1. Therefore cos inverse will be from minus 1 to 1 till 0 to pi. Okay, so that's how the graph, see, graph will be now like this, only in the positive side. Okay, so you will not have these values, so only positive. So 0, and this is 90, and this is 180. I'll select. Okay, so that will be for pi it will be minus 1. So for 0 it will be 1. When the angle is 0, the value will be 1, correct? Okay, so it will be like this, it will be like this. All right, so from 1 to minus 1, so it will come like this. So for minus 1 it will be pi. So for minus 1 it will be pi. All right, so only that branch is enough for us, and that is the inverse cosine function. We'll continue to understand what about tan inverse, okay, and the next functions. Well, so thank you very much for watching this video, and please understand the existence of inverse functions and their domain and codomain. So that will be very helpful for you to understand the next concept. So once again, thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.